So there's going to cover the review for exam 2 study guide, and I want to remind you that if you turn it in completed, I'm going to grade it by completion. You get 10 points. If you only do half, you only get 5 points. So that is up to you. We were going to work this identity. So what I'm going to do is work it from left to right, and I'm going to start with making secant 1 over cosine. Then cosine is just cosine over 1. Then we notice they do not have the same denominator, so that's our first step to make the same denominator. So it will be the product of 1 times cosine x. So the first fraction already has that denominator, so we don't do anything to the top. However, the second fraction, we need to multiply by cosine x because we want to have the exact same denominator here. So if we do that to the top, to the bottom, we have to do it to the top as well.
So would it be cosine squared x or cosine x squared?
Square x. So anytime you guys have a cosine x times cosine x, it will be cosine square x. So what you square is the cosine, not the angle. Okay?
So and when it's cosine x squared?
It will look like this. Like for example, the formula is called power reducing, like this. Okay. Next, well, they have the same denominator, so I'm going to put them under 1 fraction, cosine x. So we have 1 minus cosine square x. And then if you look at your right side, because you should always try to do that, does it look like we have cosine there? No, not at all, right? In fact, I might be thinking, how am I going to get sine? But there's always a lifesaver. How do we call that?
Okay.
Pythagorean identity. And remember, I'm not going to give you that formula. You have to know it. So it is sine square x plus cosine square x equals 1. So if I do the following, I leave my 1 on the right side, and then I take this positive cosine x to the left, like that, it will be minus cosine square x. And then on the right side, I will have sine square x. So what I'm going to do is replace this expression here with sine square x. And so that will be the next step. Sine square x over cosine x. We're almost there. Now we could split this one or factor it into
2 sines.
Sine x. Well, sine x times sine x. Because if I say 2 sines, then that could be like 2 times sine x.
2 sines.
So then we do that, and then I'm going to put cosine x under here. And then I'm going to, by the associative property, you can group those two together. And what do you get? Sine over cosine is? Tangent. And then we have sine x. Okay, and that's it. Okay, so I'm going to move on to the next one. Well, you guys remember, we're trying to cover more problems.
You guys can look at it later.
Don't be mean. It's Women's History Month.
Hey, women, you guys can look at it after.
Okay.
In the video.
So I'm gonna take the next problem. Okay. Now this one, it's actually pretty fun. So you guys see we have a sine square x, and then we gotta prove that is 1, right? So it's kind of weird. So let's start by rewriting what's in the parentheses. What is by the quotient identity? What is cotangent equivalent to? Very good. So just make them square. So we're going to have cosine square x over sine square x. Then what I'm going to do is distribute the sine square x. So sine square x times 1 will be sine square x. And then I'm going to do that to the other fraction, to the other term, which happens to be a fraction. And that will be sine, remember this is sine square x over 1. So we're essentially just multiplying sine square x times cosine square x. So that would be sine square x, cosine square x, and then we divide here by sine square x. It was already here on the bottom. Now, if we divide this 2, what does that equal to? Sine square over sine square? It's just 1. So we just have sine square x plus 1 cosine square x. And isn't it true by the Pythagorean identity that that is equal to 1? Yeah.
So with these types of problems, like on this first section on the verify each identity,
yes,
all we need is the Pythagorean identity.
Yeah, that is very helpful. Yeah. And
We don't need any other formulas or anything?
Well, I don't think I will give you an identity that, well, I might give you one that requires one of the formulas given. Okay, so let's get the next problem. There we go. Okay, so that's the next problem. And what I'm going to do first is, I don't remember what I did on the other one. Okay, so same stuff, common denominator. So we want our common denominator to be the product of that times the other. All right? So that will be 1 minus sine x times cosine x. The other fraction, same thing. We want it to have the same. 1 minus sine x times cosine x. Okay, so first fraction is lacking of that factor on the denominator, cosine x. So whatever we multiply the bottom, we have to multiply the top. And then we multiply these two numerators, and we're going to get cosine square x. Then for the second fraction, it has the denominator cosine x, so it needs this one, right? So that's what we're going to multiply the top and bottom of the fraction. 1 minus sine x. So we're going to have the following. 1 minus sine x multiplied by itself. So essentially we're saying that squared. Okay, so once we have something like that, 1 minus sine x multiplied by 1 minus sine x, it will be 1 minus the product of 1 times negative sine x, and then we double it. And I actually forgot to do that on my first period, during my first period class. So negative 2 sine x. And then we square this one. So that would be plus sine squared. Okay, so here we got so far cosine square x. And I'm going to put everything under one fraction, so 1 minus sine x. I'm not going to multiply those, but now I'm going to write the expanded form of this binomial square, which is what I did up here, this one. So we're going to replace that one. So it was 1 plus 1 minus 2 sine x plus sine square x. Okay, now you can see that we're going to have another Pythagorean identity here, right? So those two combined, added, they equal 1. Yes, are we okay with that?
Yes.
So 1 plus 1 minus 2 sine x over everything 1 minus sine x times cosine x. Okay, and you notice that you need secant, right? That's where you're trying to get. So how can we get secant? From sine? No, from cosine. So then we need to start thinking about getting rid of that sign, get it out of there. So we could add these two numbers. 1 plus 1 is 2. 2 minus 2 sine x over 1 minus sine x times cosine x. And what do these two terms have in common? The 2. So we factor out the 2 like the GCF, the greatest common factor. And when we factor a number out or a term, it's like we're dividing, right? So 2 divided by 2 is 1. And then negative 2 sine x divided by 2 is going to be negative sine x. And then on the bottom, we still have those two products for the denominator, 1 minus sine x times cosine x. And of course, we can cancel those two out. And then we get 2 over cosine, which
Is secant.
2 times secant. Yes. And give us a few seconds.
I get it.
Okay, and I don't want you to feel discouraged about identities. I'll give you 1 or 2. I'm not gonna lie. Yeah, 1 or 2. No. I'm already giving you 10 points with the study.
Can we do another section? I mean,
Do what?
another section. Like not just numbers,
do all this
not
study
just
guide?
question 1. Like, can we do
Oh, like,
like a little bit of everything before?
let's do this one, because this one, do you guys think you can do this one?
Easy.
Yeah.
Yes.
No.
I'll skip
Okay.
it in the test.
I'm just gonna solve it. And then we'll move on to number 2. I can't do the whole study guide because then I will just be given extra credit to myself.
Promotion.
But I know that you guys love identity, so.
Yes. Overjoyed.
I actually like them a lot.
So do you feel offended right now?
I forget everything once I see them.
Okay, alright, let's try this together. You guys gotta tell me what to do.
Alright, so you put the 1?
So then you go to math. Just kidding. I don't even have a phone.
Okay, what should I do with the left side?
You need a common what?
Yes, yes.
You need common denominators, so you multiply sine x minus 1. Yeah, cool.
Alright, very good. Now someone else needs to tell me what do I need to multiply the first fraction by, top and bottom?
Where are the minus ones?
Oh,
Yeah.
there should be minus. Okay.
They
Thank you, Carlos. Okay, so first fraction, what do I need to multiply by? Anyone?
Sine x plus 1.
So the factor that it doesn't have. Very good, Jeremy. Sine x plus 1. Sine x plus 1. So then here we multiply here and we just get sine x plus 1. Done. What do I need to multiply my second fraction by, top and bottom?
Negative 1.
Not just negative 1. Don't
Sine
forget
x
the whole
negative
thing. This whole
Sine x negative 1.
So sine x negative 1, top and bottom, sine x minus 1. So that times 1 is just sine x minus 1. Okay, now someone else, someone else who has not answered, what do we do next, since they have the same denominator? We put them together. So sine x minus 1 times sine x plus 1. We put everything in that is with the green marker together. So sine x plus 1 plus sine x minus 1. And then what happens with the numbers?
Or just be 2 sine x, because you cancel out.
So 2 sine x over
Sine
sine x
squared
minus
x
1.
plus 1.
What did you say? You didn't say the same thing.
Oh, you didn't. Okay, now.
Okay, but that's actually good. That was my next step, actually. So if we were to multiply, because let's look at what we are trying to get. Oh, that's not it. Yes. We're trying to get tangent and we're trying to get secant. And we know that there's no way to get secant
Without the tangent.
without cosine.
Cosine.
Oh.
But we have cosine so far, right here.
No.
We don't. So how are we going to get a cosine?
We get it from that.
From where?
From the
Denominator.
equation.
So
Your equation.
we're going to have to somehow get a Pythagorean identity. So if we multiply these two binomials, it's like when you have a minus b times a plus b. And then you end up with a squared minus b squared, like a difference of squares. So we do that here, and we're going to get sine square x minus 1. That's what it is.
No,
What?
plus 1.
No, negative times positive.
It's a negative
And then you
row.
square it?
No. You're thinking about if it was like
Sine is already squared.
like one of these.
What?
You're
Sine
thinking
is
like if it was like that.
Yeah,
The
isn't
sign
it,
is
isn't
squared,
it like
not the
that?
number.
No, the sine is squared already. It's right there.
Oh, no wonder. Okay.
Okay.
Yeah.
So then we think about the Pythagorean identity, and there is one variation of it. So sine square x plus cosine square x is equal to 1. So there's one that says sine square x, if I take this positive 1 to the left, it will be minus 1. And then take the cosine square x to the right, so it will become negative. So minus cosine square x. So what I'm going to do is replace this denominator with that expression, negative cosine square x. So now we get 2 sine x over negative cosine square x. Now what I'm going to do is place the negative on the numerator.
Well, why?
This one, because it's okay, as long as it's only in one, the numerator or denominator, but never both. So negative 2 sine x. And then the cosine square x, I'm going to factor it into cosine x times cosine x. So then we group these two together, and what do we get? Tangent. And then what do we get? 1 over cosine?
Bro.
C. Okay? And that's it. Come on, next.
They really blew me away.
Okay, now we're going to do problem 2 because you will have one like that, for sure. Yes, the whole thing. And it's usually worth like 16 points.
Oh my god. How much is identity, sir?
Yes, I am recording, Andrew.
Please say it.
Okay. So, first of all, guys, this problem is worth a lot. And you can get it wrong. Like, the whole thing wrong just because you don't draw your angles correctly. Just because. So, you have to read it carefully because the one on the exam is not going to be the same as this one. I'm warning you. So don't get to the exam and try to do exactly what you did on the practice. Okay? You have to read the instructions. For this one, we have sine of an angle in quadrant 1. Right? And then we have another angle. You guys notice there are 2 different variables. We have alpha and we have beta. The other one is in quadrant 2. Like that. So what I'm going to do is first, I'm going to draw my angles. So in quadrant 1, we have the sine the sine of alpha is 3 over 5, and that is the opposite over hypotenuse. So 1, 2, 3, or the y value. So this is 3, this is 5, and if you know your Pythagorean triples, you should know this is 4. If not, then you should do Pythagorean theorem, and you're too old to not know the Pythagorean theorem. If you were looking for a side, it will be the square root of c squared minus a squared. Okay? Then we need to find the cosine, because if you remember, for all of these formulas, we're going to need cosine. Well, maybe not for this one. But, so we need cosine, and that will equal to adjacent, so 4 over hypotenuse, 5. Will both be positive?
Yeah.
Yes. Quadrant 1, both are positive. Jerry, can you turn on the AC? All right, so let's graph the other, just move the blue thing to 70. Okay, now let's graph the other angle, angle beta. And so, well, let's say this is helpful. So now beta is in quadrant 2, the terminal side. And the it's going to be like something like that. So this is 5, the opposite side, because we're given the sine of beta. It's 5 over 13. So the hypotenuse is 13.
12.
And this is 12. So then the cosine, is it 12 or negative 12?
Negative.
Negative, because the x's are negative in the second quadrant. So negative 12 over 13. So then after you have that, perhaps we should get the tangent as well. So the tangent of alpha will be 3 over 4. And the tangent of beta, is there going to be positive or negative? Negative. 5 over 12. So all those little numbers, you guys have to keep them handy because you're going to need them once you start solving the problems. Now, what will happen if we forget that this is negative? Most of it will be wrong. Okay, so what you will do next, for example, this will be, the formula is the cosine of the first angle times the cosine of the second angle minus, is it right? Can someone verify this with the formula sheet?
Yes, that's right. You're going to give us that.
Yes, the same sheet that you have.
What
Just
sheet?
bring it with
What sheet?
the formula sheet.
You gave us one?
Yes.
They didn't. I don't have one.
Okay. So then I'm going to take the values, cosine alpha, I'm going to take it from here. 4 over 5. So I'm going to replace the trigonometric expression with the ratio, with numbers. And then we have cosine beta, so that will be times negative 12 over 13. And then we have minus sine alpha, which is 5 over 13. And then times sine beta, which is 5 over 13. No, wait, I did something wrong. There should be a 3. You see how easy it is to make a mistake? So for the sine alpha, it should have been here. 3 over 5. Okay, then we need to multiply them. So of course, it will be negative 48 over 65 minus 15 over 65. And then I believe that's negative
63.
63, thank you, over 60. That's the solution. I'm not going to do all of those A, B, C, D, E.
Well, that's easy.
But, for example, this one, remember you need to know the formula.
You're going to give it to us?
Nope, you need to know that formula. 2 sine alpha cosine f. That's the formula. Okay. Do we have any questions? Do you guys want me to do the half angle one?
Yeah.
Okay.
Wait, Miss, can you print me out one of those formula sheets?
Because you didn't give anyone one.
No.
No.
Not this
You
period?
gave us because we stayed after and we asked you for one.
Okay, I'll print you guys.
Oh, wow. Thank you.
Okay. All right, so. Okay. All right, we're gonna do the last one. Let me borrow your phone.
I left them at home.
Okay, now for that one, if you guys notice, you have two. Okay, let me talk first about the angle here. Angle beta is not the reference angle that you see here. The angle beta is actually starting from here, and then it goes here. That's angle beta, okay? So for this question, we know that the cosine of beta is negative because the terminal side is in quadrant 2. However, if you cut that angle in half, it will be something like here, perhaps, right? So that will be in quadrant 1, half of angle beta. So is the cosine positive or negative in quadrant 1? Positive, because the x is positive. So on your formula sheet that you don't have, that I will print them in a minute, you have something that says positive square root or negative square root, but don't choose both, only one. So in this case, we're going to work with the positive, all right? So I'm going to pause the video so I can print those formula sheets.
Thanks.
So I want you guys to look at the formula sheet, and these are the two that I was talking about. Right? So in this case, we take the first one because we already established how that angle, the half of the angle of angle beta was going to be in quadrant 1. So that would be the square root of 1 plus cosine beta over 2. So 1 plus cosine beta over 2. Now, make sure you take the correct angle, guys. Because your formula sheet says alpha, but the question says beta. Yeah? Are we okay? So,
Because how do we know when we use a positive and what we use?
depending on the terminal side of the half angle. So, for example, if the terminal side of the half angle was in quadrant 2, you will use the negative. Because the cosine is negative in quadrant. I don't know. Those are questions you don't ever want to ask. Okay, so 1 plus the cosine of beta, we have it from over here. And it's this one. Negative 12 over 13. What other formulas do you guys need to know for the test? Law of sines?
Pythagorean identity.
Yes, and also the law of cosines. And also Heron's formula. The one that goes like this, S minus A, S minus B, S minus C. You know, I'll just give you guys that. Okay, so we go here, inside the radical, we're going to combine the numerator first. So that's going to be 13 over 13 minus 12 over 13, everything divided by 2. So it's going to be 1 over 13 divided by 2 over 1. So that's going to be the square root of 1 over 26. So you could also say something like the square root of 1 over the square root of 26, which will be 1 over the square root of 26. If you feel like rationalizing it, then it will be the square root of 26 over 26. Now, how can you earn partial credit? Well, if you get your answer wrong, I'm not even going to look at your work unless you have copied the formula first. If you don't do that, I'm not going to give you partial credit because that's you. Your mistake. My advice is that first you identify, plot your angles, draw them, identify the sine, cosine, tangent. Then you start with your problems. Verify that you're in the right quadrants and that your signs are correct, positive or negative. That's very important. Next, you need to write down the formula from your formula sheet. If you don't write your formula and you get the final answer wrong, I'm not going to give you partial credit. Is that clear? Yes?
It's like a net positive.
Okay, now let's just move on to the equation. Do I have what? No, you could, if you don't feel like rationalizing, just leave it like that. It's fine. Especially if you're short on time. When I grade them, I have all the answers with me, like all the possibilities that are correct. Okay, so I would like to. Someone asked me about 4. 4 is very simple, guys. Don't be discouraged. You could really get those points. That should be at 15 degrees, okay? For example, that's the formula that I was talking about, the cosine of a double angle. And so that one is equal to cosine square of theta minus sine square of theta. So you have to recognize that that is this formula, double angle. So you're going to say something like, if theta is that angle that you have on the problem for A is 15 degrees, what should 2 theta be? 30, okay? And so that expression turns into the cosine of 30. And we all know that is the square root of 3 over 2. The next one, if you look at your formula sheets, is the tangent of a double angle. Do you guys see it on your formula sheet? It's like double angle tangent to theta. So in this case, this 5 pi over 12 is equal to theta. So then 2 theta is going to be 2 times the 5 pi over 12. So that will be 10 pi over 12, which is actually 5 pi over 6. So this expression is representing the tangent of 5 pi over 6. Okay. And the tangent of 5 pi over 6, I don't know it off the top of my head. But I know what the sine and the cosine is. And moreover, you guys will have a calculator, so are you allowed to type that in a calculator? Yeah. Why not? But if you don't want to, it will be 5 pi over 6 is located here. So the sine of 5 pi over 6, it should be positive 1/2. And the cosine of 5 pi over 6 is equal to negative square root of 3 over 2. So if we multiply those, we're going to get negative 2 over 2 square root of 3, which will cancel the 2's. And so that will be negative 1 over the square root of 3. Like that. And you don't need to rationalize it. Leave it like that. If you rationalize, it will be negative square root of 3 over 3. Okay, now this one, just cross it out because I wrote it wrong. So what I was trying to express was like the sine of a double angle. So I guess we could, if we were to put a 2 here and then a cosine of 22.5 degrees. And so if we do that, it will be the same as the sine of 45, which is the square root of 2 over 2. So my question was written wrong. Okay? That was a problem. Okay, number 5 is very easy. I think you can do that. Refer to section 5.4 for those. And you have the formulas. Okay, now the equations. And I know we're almost out of time. And some equations, at least one or two. Okay, so I'm going to do two, number 8 and number 9. They're very fast. And it's very likely that you will have one solution, okay? Okay, well, the equation is, can someone read it to me, please? Well, it's right here. Let's do it right here. So, you see here, it says, oh, you have another tangent here. It says, you see a hint? Factor tangent x out. Before you can factor it, you have to move everything to one side. So this positive 3 tangent x, move it to the left, it will be minus 3 tangent x. And then the right side equals 0. Now, you follow the hint, which says factor tangent x out because they both have it. Both terms have tangent x. So if we factor out tangent x, we're going to get sine square x minus 3 equals 0, like that. Now, once you have two factors equaling 0, you apply the zero factor property, you take each factor equal to 0, and then solve for x. So, if we take tangent x equals 0, where will the tangent be equal to 0? Anywhere where the sine is also equal to 0. And so, that happens here and here. So, at 0 radians and at pi radians. Okay, now if we take the other factor, this one, and we say sine squared x minus 3 equals 0, and then we solve for x, it will be sine squared x is equal to 3. Then we have to take a square root, and so that will give us sine x is equal to the square root of 3. Now, in this case, I want you to remember something. What is the range of the sine curve? It goes from negative 1 to, and this is a very bad graph. You know that, right? But the thing here is, where did it go? Okay, well, the square root of 3, where is it? I lost it. Anyways, we had something that said like sine of x is equal to the square root of 3. So right here it will be no solution because the square root of 3 is bigger than 1. Yeah? Does that make sense? So then the only solutions that you will take are the ones that we found on the other, from the other factor. Oh, it's in this minute. You're right. Only the things that we know, the 0 and the pi. From here we get no solution. Okay, I'm going to try to do the other one. Where is it?
This is
Number 9. Okay, let's see if this will work. Okay, great. Okay, so it says solve this equation And then the hint says use the double angle identity for sine. The one that you have to memorize. The one that is 2 times the sine of x times the cosine of x. Now, so you replace this part with that. You still have cosine x here. So then we're going to work like the other problem, similar to it. We bring the cosine to the left. And then the right side equals 0. Then we factor out the cosine x. So if we factor cosine x from here, we're going to get 2 sine x. If we factor cosine x from there, we're going to get minus 1. Then we take each factor, equal it to 0. So here, where is the cosine equal to 0? It will be whenever the x is 0, right? On the unit circle, it happens at pi over 2 and at 3 pi over 2. So x is equal to pi over 2 and 3 pi over 2. From this factor, we take it, equal it to 0, and then we solve for x. So sine x is going to be, we take this negative 1 across, it becomes positive 1. And then this 2 is multiplying, so we divide by 2. So then x, the sine of x is 1/2. Well, it's my favorite at pi over 6. And there's one more. Where's that other one? In which quadrant? Very good. 5 pi over 6. Okay. And that's it. We're done.